Thanks for tuning in to the Lean 911 podcast, where you'll have a voice directly from the Gemba. I will rely on my 3 decades of Lean successes as well as my failures to answer your most challenging questions regarding your Lean transformation. I'm your host, Mark DeLuzio, President and CEO of Lean Horizons Consulting and the Principal Architect of the Danaher Business System. Looking forward to your questions. Now, let's go to the Gemba. Welcome to the Lean 911 podcast. This is episode 2. My name is Mark DeLuzio, CEO and President of Lean Horizons Consulting and the Principal Architect of the Danaher Business System. We're broadcasting from sunny Scottsdale, Arizona. Well, it's not too sunny right now because it's 8:40 at night, but we had a great day today, and it's going to be sunny again tomorrow. So anyway, for those of you up in New England, my friends up there in the Northeast, come on down. Weather's fine. Last time we talked about standard work. And I anticipate standard work we're going to have many more sessions on standard work because there are a lot of questions. We can only do so many in one podcast. And you'll have the opportunity over time to write in your questions or call with your questions, and we'll answer all of those. I think this week, episode 2, single minute exchange a die, is going to be very similar because it's a controversial type of thing in terms of how we do SMED. Single minute exchange of die, or otherwise known as quick changeover, and why it's needed, how you do it, and all that. So there's a lot of sometimes mystery and misconceptions about what this is all about. So I'm going to try to take you through some of the basic questions that I've been asked already about single minute exchange of die, or SMED. And like I said, I think we're going to probably have a lot of sessions on this as we move forward. Understand that all of these things that we talk about are interrelated. They don't stand by themselves. I can't talk about single minute exchange of die, without talking about 5S, without talking about visual management, standard work, Kanban, and how it relates to Kanban. All of these things are intermingled. So keep that in mind as we pick these subjects. One of the reasons we did that is so you can catalog certain topics so you can look them up down the line, but you'll see us referring to a lot of different types of things in Lean as we go through each and every one of these. So let's get going. A single minute exchange of die is one of the first things that Toyota did way back in the 50s after World War II. And what happened was they didn't have the resources. They didn't have the resources to compete with the American auto manufacturers. So if you looked at GM, Ford, Chrysler at the time, they had large capital investments. Japan had very limited resources. So they couldn't dedicate, for example, a stamping press to a hood or to a trunk or to a door. They had to change over because they had limited equipment. So the nicety of having all that equipment, wasn't there. That gave rights to this. So let's get into single minute exchange of die. I'm going to answer some of the more common questions as it relates to this. And hopefully this will clarify some of the things that you've been going through with this particular one. So first question is, what is SMED? SMED, SMED, single minute exchange of dies. Why was it developed as a Lean methodology? I just explained that Japan had limited resources. Now, the fellow who invented this was a guy named Shingo. He lived from 1909 to 1990. The Shingo Prize is named after him. I am also a recipient in that Hall of Fame, if you will, of the Shingo Prize. And I also know his son, Ratusi Shingo. So he's carrying on in his father's footsteps as we move through. Now, Shingo didn't only invent single minute exchange of dies. He had a lot of other contributions with Taishi Ono on the Toyota production system. But for today, we're going to focus more on single minute exchange. So one of the questions is, what is the ideal changeover time? First question people kind of ask. What's the ideal changeover time? It's 0. We don't want any changeover. And as you'll see, changeover is an abnormality. The best option is 0, or what we might call single touch changeover, where changeover happens almost automatically. The next best option is you want your changeover times to be within takt time. You want to be able to change over so that you're just missing one unit as you're changing over from Model A to Model B. And if you could do this right, you can actually follow in a one-piece flow cell a changeover right behind the last Model A being produced to the next changeover to Model B. So you're only missing one cycle, one takt time, one part to change over. When you get really good, you can follow yourself that way. So that's the second best option. Can you change over within your takt time? Other than that, anything above that, you got to get it down. Even though we call this single minute exchange of die, if you get down to, let's say, 9 minutes, but your takt time is 20 seconds, you're missing, 18, 20 parts if you're at a 9-minute changeover time. So that's not good enough. You got to get down within takt time. Shingo believed that changeover could be reduced. Any changeover, when you start out, can be reduced by 59/60ths. So if you had a 60-second changeover, he believes it could be 1 second. If you had a 60-minute changeover, he believes you can get it down to 1 minute. That was his philosophy. Now, it's not just theory, because he actually did it. And as a matter of fact, so did we here at Lean Horizons. But it takes a lot of work. You'll be able to get the first, 50, 60, 70% in a relatively short period of time by doing some of the basics. But as you get through after that in subsequent Kaizens, you'll find that the gains are smaller, but the benefits are exponential when you do it. So we'll talk a little bit more about what the impact is on inventory, on lead time, and ultimately on cost. So, the best you can, Shingo says if you can eliminate it, great. No changeover is the best, but he believed any changeover can get down 59/60ths. Do you deduct changeover time from your total available time when calculating takt time? Now, I talked about this in my standard work podcast in episode 1. The answer is a clear no. You do not deduct changeover time. Why? First of all, it's not standard. Second of all, it's an abnormality. You've got to look at changeover time as an abnormality. It's something that prohibits you from working to your standard work. No different than a machine going down, a supplier, delivery problem, a quality problem, an operator issue, whatever it may be. You've got to look at changeover as not something that is just something we get used to because it's a nature of manufacturing. We've got to change our mindset and look at changeover as an abnormality. So the answer is absolutely not. You don't take it out of takt time. Now people say, well, geez, Mark, if I, don't take it out of my available time when I calculate takt time, I'm not going to make my production. Exactly. We want to show that delta. We want to show that deviation with standard work. Now, that may mean that you have to work overtime. You might run this out with more people, but don't change your standard work. I talked about that in the standard work podcast. You do not change your standard to account for abnormalities. That's why we call it standard. Now, when you don't hit that standard, you're going to want to know why. If you bury this in to your calculation, you'll never see changeover as an abnormality. So the answer on that was an emphatic no. You do not take the time out of your takt time calculation. And by the way, what are you going to use? What times are you going to use? Are you going to use an average? Maybe today I don't change over. Maybe I change over once a week. Let's say I have an 8-hour changeover and I only do it once a week. What do? Take an hour out a day? That doesn't make any sense. Now I don't have a standard I can really base my performance on. So the answer is no. We were taught to avoid changeovers. This is a question that comes up all the time. Why do you suggest we do more changeovers? All right, well, back in the old MRP Ollie White days, they had this formula called EOQ, Economic Order Quantity. And it was designed to actually avoid changeovers, which basically meant you're going to produce in large batches, which is something you definitely don't want to do. Why? because you're going to violate just-in-time principles. You're going to be making things that are not needed, and you're going to be sucking up capacity on something that is needed. So if you have, let's say, 4 models that you need to make, doesn't matter what they are, A, B, C, and D. And I make large batches because I want to avoid changeovers. While I'm making part A or model A, part number A, I'm not making B, and I might have demand for B. But B's got to wait. If I can reduce my changeover, there is an absolute direct relationship between batch size, between lead time, and inventory. And I'll get into this a little bit later when you reduce your changeover. So if you reduce your changeover by 50%, you will reduce your lead time and your inventory, provided that you're working on a level loaded Heijunka-based schedule. Again, you see how these other tools come into play relative to this particular thing we're talking about here, which is single minute exchange of die. All right. It has an impact on your Kanban quantities. If you have a signal Kanban, it will have an impact on how much inventory you're carrying there. And again, there's a direct relationship. If you have 1,000 units in your Kanban and you reduce your changeover for that piece of equipment by 50%, you could bring it down to, to half that size, to 500 units. And that's all lead time. That's all inventory. That's all cost. So when you do this, when you actually reduce and go to smaller batches or smaller lot sizes, if you will, ideal lot size, of course, is one piece flow. But as you move this down and take your changeover times down, you'll have shorter lead times, higher on-time delivery, greater responsiveness, less expediting. How many people do that all day? Reduced inventory, as we talked about, less obsolescence, lower overall costs. It's incredible if you can do this. It's interesting because when I was in Japan one time, I did several study missions with Shingijutsu, with Mr. Nikao in particular. And he was my main mentor along with Iwata. I had about 30 Danaher executives with me at this one particular factory. As a matter of fact, I think this factory is where Tasha Ono actually worked. And what they made was all these parts that went into the dashboard for Toyota, the plastic, the vents and the knobs and all that stuff. They would assemble these kits that they would install these dashboards into the cars at Toyota. And they were delivering, I think, every 2 hours to Toyota. By the way, this plant, we were arguing whether or not this plant was turning inventory 300 or 700 times a year. It was incredible. One of the most amazing plants I've been to. So anyway, they had a bank of injection molding machines. Now, the president was showing us around. I was leading the pack with the president. Had 30 Danaher executives behind me. Matter of fact, I think at that particular trip, Larry Culp, who's now the CEO of GE, was with us. And as we're walking by the injection molding machines, I said to the president, how long does it take to change over an injection molding machine? And he responded to me by saying, 1 minute. I said, 1 minute? Are you kidding me? And he looked at me, well, why are you surprised at that? Well, the best I've seen was 15 minutes. And that was at a Japanese Nippon Denso plant in Tennessee. So anyway, I said, well, thank you. When are you going to do your next changeover? He says, not till 2 o'clock in the afternoon. How many presidents out there know when they're going to do the next changeover? Okay, think about that. I said, okay, well, thank you, because we were there in the morning. Deluzio-san, would you like to see a changeover? And I'm like, are you kidding me? You're going to do a changeover for me? He calls his 2 changeover guys over, his changeover team, and we're going to talk about that in a minute. They do a changeover. I timed it. It was 55 seconds. We all applauded. They bowed. Then they changed it back to the original part number. Okay. Again, minute. The president looked at me and says, Deluzio-san, thank you for giving us the opportunity to practice a changeover. And I was blown away by that. Go into one of your plants and ask them to do a changeover now right when you're there. See what they tell you. They looked at this as, hey, you gave us an opportunity to practice. And, we're going to talk about the pit crew type mentality in a minute. And that whole experience was a different mindset. So anyway, smaller batches, you will reap the benefits. You got to get good at changeovers. How will improve setup times reduce my lead times as well as my inventory? I like to use real life examples. So let's just say that you're making hot dogs and hamburgers for a group of 10, 20 friends and family. How many people out there just put the hamburgers on the grill and then later cook the hot dogs? My guess is nobody. What you probably do is you put hot dogs and hamburgers on the grill. Why? If I'm a guy that wants hot dogs and I got to wait for all the hamburgers to be made, that's lead time. So if you're going to spend a week making part A and I'm ordering part B, at minimum, I got to wait a week. Then you got to make it and ship it and do all that stuff. But if you're making part A and B every day, if you're making hot dogs and hamburgers every day, everybody's going to get fed at the same time. As a matter of fact, you might have a customer that orders part A and part B, and they want them together. Well, how are you going to do that? You're going to hold up the whole order, stock A's after you make them, change over on the weekend, and do B? No, you're not going to do that. You don't want to do that. You probably do that. Many people do. I've seen. You don't want to do that. You don't want your guests to wait for hot dogs or hamburgers. You want them to eat together. So intuitively, you have to make your hot dogs and your hamburgers with zero changeover. Okay. No wait time. That's the analogy you think about lead time and as well as inventory, right? So that's what you want to look at here, because that inventory is going to get consumed all at the same time. Use real life examples. And this analogy with hot dogs and hamburgers is an exact analogy for any business out there that has changeover. Now, this is an interesting one. The question is, why would you suggest that we develop a dedicated setup team? Shouldn't the operators do the setups? This was a big controversy on LinkedIn. And the comments I got were, well, it's not going to be productive. We're going to lose productivity. You're going to waste a lot of people's time, blah, 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 right? Well, hey, look, if you don't have a lot of need for changeover, then dedicating people to changeover might not be the best thing to do. But most companies have a lot of changeovers, or put it this way, they should have a lot of changeovers, but they don't because they're so long and costly. So they say, oh, geez, we only do, 4 changeovers per month. You probably should be doing 4 per day if you really think about it, but you're not. So you don't see the value in actually a dedicated setup team. So again, real life analogy, I like to use a pit crew in an auto race, whether it's NASCAR, Formula One, Indy 500. The driver is the operator. Operators should operate, according to Chihiro Nakao. I talked about this in standard work. Operators should operate. They should be working in their work sequence of standard work. That work sequence is analogous to the racetrack. We want to keep that driver on that racetrack as much as possible and keep him out of the pits. So what does that mean? That means I don't want the operator going to fetch tools or fetch materials. I want the operator in the cell working the standard work according to the work sequence as laid out by the standard work combination sheet. So now what does that mean? That means a pit crew. And Sigio Shingo, by the way, really supports a pit crew mentality. He doesn't call it that, but he calls it dedicated changeover people who have technical competence and they practice changeovers, just like a pit crew does 6 days a week until the race day. They practice every day to shave off half a second here, a quarter of a second here. They don't just show up on race day on Sunday and say, hey, okay, let's do a changeover. They change out the tires, fill up the gas tank. We don't want the driver getting out doing that. They'll lose the race. So think about the pit crew. Think about your business and your production as, quite frankly, a race. You're racing against competition. You're racing to get product at the right quantity and a just-in-time concept to your customer. And of course, in the right quality. So the answer is absolutely yes. you should have a dedicated changeover team that has the technical competence to do quick changeover, following the rules of single minute exchange of data. Now we're going to go through the training today in terms of how to do a SMED. That's subject for another day, and that's not what this podcast is all about. We're just answering these questions right now that all come up, and this is a big one. This is a big one, and everybody argues about it. And I'm here to tell you that every company I've seen in Japan that were Toyota suppliers had dedicated changeover crews. The next question is, I've heard the words internal and external changeover time. What's the difference? What do they mean? Well, if you think about it, internal time is the setup activities that cannot be done while the machine is running. So in other words, if I'm changing out a fixture on a CNC machine or a mold on an injection molding machine, the machine can't be running while I'm doing that, right? So that's all that time it takes to do that type of stuff that the machine actually has to be done is called internal time. External time are those activities that can be done when the machine is running. So for example, getting my tools together, by bringing those tools to the point of where the changeover is going to be, I don't need to have the machine shut down and then do that. It extends my changeover time. So I can get that all done in advance. I can preheat a mold on an injection molding machine. I can set up all my tooling that needs to be changed out and my fixtures all ready to go. While the machine is running Model A, and I'm going to change over to Model B, I'm getting set up for Model B. All that's external time. Now, what happens is when we first start doing changeover, and one of the biggest opportunities that we see is people wait till the machine is down with Model A, and then they do the complete 100% changeover, which includes external and internal time. So in other words, anything that can be done externally is they wait until the machine is down, so they're actually doing it internally. So one of the first steps in changeover is separating your internal and your external activities, and you get a lot of bang for the buck. Now think about this. It's the internal time that has an impact on your customer and on your lead time to the customer. The external time has an impact on cost, right? So we want to get external time down to reduce cost. Oh yeah, by the way, we want to get internal time down to reduce cost too. But it's the internal time that actually has the impact on your delivery to the customer, because that's when the machine is either running or it's not. So, we'd get more into this in actual training, but the difference between the two, what can you do before that machine shuts down on Model A when you're getting ready to set up for Model B? That's the question, internal versus external. Why are both considered an enemy of quick changeover? Did you ever screw in a bolt and you're screwing the thing in maybe 10, 20, 30 times until it gets to the end, and then it finally tightens? And you got to ask yourself, why did they design this bolt to be 3 inches long when it only really needed to be half an inch? Because 99% of turning a bolt is non-value added. Only the last turn or so truly adds value, and that's where the bolt tightens to the fixture or whatever it is you're trying to tighten. So now the question is, well, why do we use bolts? Should we use bolts? The answer clearly is no. We should get rid of bolts, go to quick clamps or other devices to hold things together. Quick release manifolds, for example. We don't want to be turning bolts. Bolts are your enemy. And one of the other things I'll tell you about changeover is you want your operators to have their hands moving, but their feet staying still. You do not want your changeover operators, as best you can, to move. They should be stationary with all their tools and everything right at the point of changeover. So you can move your hands, but not your feet. Now, can you do that like overnight? No, but it's something to strive for, where the operator doesn't have to move. Feet stay still, hands move. All right. So think about that. If you can get to that point, you'll be doing yourself a big favor. But as far as bolts go, we do not want bolts. We want to get rid of bolts. Bolts are an enemy of quick changeover. This one comes up quite a bit. I heard that overall equipment effectiveness, OEE, is actually improved by doing single minute exchange of die improvements. Is this true? Well, the answer is yes, it's true. Because what you're doing is you're keeping that machine uptime higher because you're doing less downtime with changeover. However, I'm not a big fan of OEE, and I'll tell you why. OEE has the same behavioral effect as absorption, where the more I make, the better my OEE, key performance indicator, the KPI, looks, because my machine is up. Now, I know there's other aspects of OEE, there's quality and other things, right? But the big driver with OEE is uptime. That's the biggest impact on the OEE calculation. So I have seen OEE instill the wrong behaviors in an organization. We're not going to change over from Model A to Model B because it's going to kill my OEE score. That's what my boss is looking at every day. I'm not going to do preventive maintenance because if I shut down the machine, my OEE will look bad. And if I make a lot of A's, no big deal, because the accountants are going to love me because that's going to really pad the absorption for the P&L, for the profit and loss statement. Deferring costs into the balance sheet. I don't want to do that. And I'm going to build excess inventory, obsolete inventory. I'm going to lose business. I've seen this calculation actually force companies to lose customers while they were waiting for Model B and Model C and Model D. They were driving Model A because they didn't want to change over. Now, the argument on this one is, well, Mark, if they really understood this and they really, and people really, knew the essence of OEE, they wouldn't do this. Okay, got that, right? But it doesn't happen because leaders measure their people with this measure, and human nature is what it is. If you're being measured on it and your bonus is calculated on it, you're not going to be so altruistic to say, well, I'm not going to worry about my bonus. I'm going to do what's right. It's not going to happen, and it doesn't happen. That's why I don't like this measure. So the answer is yes, it does improve. OEE measures do improve when you reduce your changeover. I just don't like the measure. Not a fan of it. And it just, it discourages more frequent changeover. What we just talked about with more frequent changeovers, it discourages it. Matter of fact, it has the opposite effect. I'm going to do bigger batches, less changeovers, because my number is going to look great for my boss. And that's all that counts. Why shouldn't we buy equipment that combines multiple process steps? Wouldn't this eliminate the need for frequent changeovers? Maybe not. I don't know. It depends on the situation. However, many times in the spirit of trying to improve productivity, in the spirit of trying to, eliminate changeovers this way, I put everything into one big machine, let's say, I'm forgetting about something very important. What I'm forgetting about is tack time. I'll end up, and I talked about this in the standard work session last time in episode 1, I'll end up violating my tack time by combining multiple operations. My machine cycle time will be greater than my tack time. So great, I might have eliminated a couple changeovers, but now I'm going to work a second shift, maybe a third shift, because I violated my tack time. My cycle time is greater than my tack time. So what we want is small equipment, ideally no changeover like we discussed. And as Nikau said, who's the father of 3P, which is the production preparation process, we did the first one at Jake Brake in the late 80s with the Hino line. I ran the Asian business in Hino. Part of Toyota was my customer. And the first 3P line was done in the US at Jake Brake, and it was an unbelievable line. We had Pokyokes and Judokas and Hanadashis and Chaka Chaku, all that stuff that goes into cell design. And we'll talk more about that at another date when we talk about cell design. Nicole's known as the father of moonshine. And his own notion with moonshine is, hey, look, we're going to take a bunch of people, engineers, what have you, put them in a room, and they're going to do mock-up production cells using things like plywood, 2x4s, aluminum, paper, cardboard, whatever's available, right? Why did he call it moonshine? Moonshining way back when the moonshiners down south would take garbage cans, garden hoses, anything that was available to make moonshine. And that's where he came up with the idea of moonshine. So he's known as the father of moonshine. I've been to some of his plants in Japan where he actually created some unbelievable choco lines and cells and just lights out incredible. And maybe someday we'll talk about automation and the questions around automation and ills and the misuse of automation in so many cases. Because the choco line does require people, and everybody wants to eliminate people. And I believe it's the wrong thing to do for a lot of different reasons. So anyway, the answer is no. We don't want, as Nicole would say, we don't want battleships. We want PT boats, nice, small, flexible, single operation pieces of equipment where I can manipulate, keep it way under takt time, simple. You know, if a big battleship goes down, the whole darn thing goes down. If one little PT boat goes down, I can replace it with another, right? So he always said no battleships, PT boats. And again, we'll get more into that when we get into the cell design section of this podcast. Okay, that's all I have this time around. There's probably a lot more questions you're going to have on single minute exchange of die. I didn't really talk too much about the impact it has on and all that, but it does definitely have an impact on your Kanban calculations. And I actually have a model. If you go on YouTube and take a look at single minute exchange of die and do a search for me there, you'll find the Kanban model where I show you directly mathematically the impact of changeover on your inventory, on your Kanban, and on your lead time. All right. So that's out there on YouTube. I might bring that in another session. We'll talk more about that. But that's it right now. Thanks for visiting. Email me at mark@lean911.com. That's Mark, M-A-R-K with a K, mark@lean911.com. And we look forward to seeing you next time. Thank you. Thanks for listening to the Lean 911 podcast. I'll be happy to address your questions or feedback on future episodes. Email me at mark@lean911.com. You can check out our other episodes by visiting our website at lean911.com, our YouTube channel, wherever you listen to podcasts. This is your host, Mark DeLuzio. Thanks for listening.